This is our notes for 9.5 area of regular polygons. And we need to review two vocab words. The first is regular. Regular means that all sides are congruent and all angles are congruent. And polygon is a multi-sided shape. And then inscribed means it's inside. So these regular polygons are inside circles, as you can see. So we just talked about circles and we talked about a radius. So radius is our first term that we're going to review here. So this is a line segment that goes from the center of the circle to any vertex of the polygon, and it is still a radius because it's hitting the edge of the circle. So anytime we connect a segment from the center to a vertex of the polygon, it's also a radius because it also goes to the edge of the circle. Now, the new term is the apothem. So the apothem connects a line segment from the center and it's perpendicular to any side of the polygon. So it does not go to the corner, it doesn't go to the vertex, it goes to one of the sides and it makes a right angle. So this would be an example of the apothem in my second picture here. So anytime I draw one of these from the center to a side and it makes a right angle, that would be an apothem. So all of these are apothems. Now, what we want to do is we want to use the radius and the apothem to create a right triangle. So in this third picture, watch what happens. I'm going to draw the apothem, and now I'm going to draw a radius very strategically so that we have a right triangle inside of our polygon. Now, as we work through these problems, the circles aren't actually going to be there. We're just going to see the polygons. So you see 3 polygons down below, and we're still going to call the segments that we're drawing radius and apothem. Even though the circle's technically gone, it is still a radius. So whenever we see our polygons and we need to find the area, the very first thing I want you to do is draw a apothem and a radius so that you create a right triangle inside. So in the second shape, the first thing I would do would be radius and apothem so that I get a right angle inside. Now, we have some very important rules that will help us out here. The apothem is also a segment bisector, which is going to create 2 congruent segments. So every time you draw an apothem, it is going to chop that side in half. Okay? Now, the next very useful rule is that the radius is also an angle bisector, which is going to give you 2 congruent angles. So every time you draw a radius, it's going to chop that angle in half. So that's going to be very helpful because we're going to be using that rule to help us figure out an angle inside of our right triangle. Now, the last rule, this is going to need, you're going to need to go back in your brain and think to chapter 5 because we need to use the little I formula, which is 180 n minus 2 over n. N is the number of sides, and it's also the number of angles that the polygon has. So we're going to use our little I formula to figure out what the individual angles are in these polygons. So if you can think back to chapter 5, each of these interior angles, those are each little i's. And so we're going to use the little I formula to figure out what their measure is. Now, your area formula is right here in blue. It's 1/2 times the perimeter. So P is the perimeter, and A, that lowercase a, is the apothem. So we have to find the perimeter and the apothem in order to find our area for these polygons. Okay, I am jumping to number 4 on the back. We're going to start with problems where we know what the apothem is. So for example 4, we are being told that lowercase a, which is the apothem, is 17. So if you remember, the very first thing I want you to do is draw an apothem and a radius so that you get a right triangle inside of your polygon. Now, the next thing that would be good to get is going to be our little I. We want to figure out what an angle is inside of this polygon. So remember, this is 180 times n minus 2 over n. So you just want to count up how many sides are there. Well, there are 11 sides. Just kidding, Miss Sangre can't count. There are 10 sides. Okay, so when we find our little I formula, this is 180 times 10 minus 2 over 10. And that's going to mean that each of these little i's is 144. And I like to pick one and I like to label it so that I don't forget. Now, the next important thing is when we drew that radius in, remember, it cuts the angle in half. So this angle inside of your triangle is 72 degrees because I took 144 and divided by 2. Now, we are also told what the apothem is. Remember, the apothem is the segment that makes the right angle with the side of the polygon. So we already have one of the important parts of our formula. The only thing we're missing is perimeter. So we're going to have to be clever here and find our perimeter. So we want to work with this little right triangle. This segment right here that I'm highlighting in blue, that's going to be what we want to find in order to eventually get our perimeter. So we're going to have to use trig because in our right triangle, we know one side and we need another side, and we do know an angle. So I know the opposite side and I want the adjacent side. So this is going to be tangent, and I have tangent of 72 is opposite over adjacent. And since the variable is in the denominator, I can switch these around. So I have 17 over tangent 72. And in the calculator, that comes out to 5.5. So that blue segment that I have highlighted is 5.5. In order to get perimeter, I want to know what an entire side of this polygon is. So if I take 5.5 and multiply it by 2, then I'll get that entire side. Because remember, these two segments are congruent because of the segment bisector with the apothem. So each side is 11. Now to get our perimeter, each side is 11 and there are 10 sides. So our perimeter is 110. Now I'm ready to use the formula because I have the perimeter and I have the apothem. So our perimeter is 110 and our apothem is 17. So area equals 1/2 perimeter times apothem, and we get 935. And this is squared kilometers. The next example I'm going to do is actually not on the note sheet. It's on the area of regular polygons worksheet. And I'm going to go all the way down to number 13 so that we can try this one. Because you'll notice what we know is the apothem. So the two things that we need to get in order to be able to use our formula is the perimeter and the apothem. And we already know the apothem. So our goal here is to get the perimeter. So if you remember, the first thing that you want to do is create that right triangle inside of your polygon. Next would be to get little I. So your little I formula is 180 times n minus 2 over n. And there are 5 sides. So this is 180 times 5 minus 2 over 5. And you should get 108 degrees. So each of those angles inside of the polygon is 108. Remember, when you draw the radius in, that gets split in half. So this angle inside of your right triangle is 54 degrees. Now we need to work on getting the perimeter, which means I want this blue piece of my right triangle. So in this right triangle, we know one angle and we know one side. So we're going to want to use trig. So the side that I know is the opposite. The side that I want is adjacent. So I'm going to use tangent of 54 equals opposite over adjacent. Since the variable is in the denominator, these will switch around. And this goes in your calculator. You should get 18.2. So this blue segment is 18.2. So if I multiply that by 2, I will get the entire side of the polygon, which is 36.4. Now all we need to do is find the perimeter. I know that each side is 36.4 and there's 5 sides. So your perimeter is 182. So now we are in really good shape because we have the apothem, it's 25, and we have the perimeter, it's 182. So now we can go ahead and do our area formula, 1/2 perimeter times apothem, and we should get 2,275 squared centimeters. Here's a summary of your steps. So the first thing to do is to draw that right triangle inside of your polygon. That's using your radius and your apothem. Then use the little I formula to get each individual angle inside of the polygon. But then most importantly, you want to divide that by 2 to get the angle that's inside of your right triangle. Step 3 is use trig or maybe a 30, 60, 90 triangle to find that bottom adjacent side of your triangle. This is our process to start to get perimeter. Step 4 is multiply whatever you got in step 3 by 2 to get the entire side of your polygon. Then step 5, multiply that by the number of sides the polygon has so that you can get perimeter. Finally, you may use the area formula because you have the perimeter and you were given the apothem.